Minimum ignition temperature test, that is MIT test for dust cloud. Information from MIT test is principally used to ensure that the plant surface temperature cannot causes auto ignition of dispersed dust. The results are also used to compare to the temperatures that may occur in equipment such as a drying oven or hot surfaces to determine if they can serve an ignition source for a potential dust cloud. The limitation of MIT test is that this test is applicable for solid sample only and not for gases or vapors as well as liquid. Test procedure. The MIT test is conducted in a Godberth Greenwald furnace. The apparatus consists of vertically mounted furnace on SS bottom plate which is open at the top and base. A glass chamber is mounted on the top of the furnace and also connected the horizontally placed sample holder. A compressed air receiver is mounted on SS bottom plate and is connected to sampler holder. Dust is dispersed using compressed air from the receiver into a sampler holder and then the observation glass and a vertical furnace. Two thermocouples are placed centrally into the furnace for measuring and monitoring the furnace temperature. The furnace is electrically preheated to 500 degrees Celsius. Known amount of sampler, say 0.5 gram, is taken into sampler holder and is dispersed into vertical furnace by compressed air set at known pressure, say 0.1 bar. Dust concentration and compressed air pressure are varied to ensure that most sensitive concentration is covered. If ignition is observed, the temperature is reduced in a step of 20 degrees Celsius till no ignition is observed. If no ignition is observed at 500 degrees Celsius, temperature is increased in a step of 50 degrees Celsius. The MIT of dust cloud is the lowest temperature of the furnace at which no ignition is observed, minus 20 degrees Celsius for furnace temperature above 300 degrees Celsius and minus 10 degrees Celsius for furnace temperature below 300 degrees Celsius. To account for the small scale screening uncertainties, second third of the MIT value is used to define the maximum. Result and interpretation. A powder having MIT value greater than 500 degrees Celsius is less sensitive to hot surface. A powder having MIT value between 200 to 500 degrees Celsius is sensitive to hot surface, and a powder having MIT value less than 200 degrees Celsius is highly sensitive to hot surfaces. A powder having MIT value greater than 500 degrees Celsius is less sensitive to hot surface, so basis of safety generally not considered. A powder having MIT value between 200 to 500 degrees Celsius is sensitive to hot surface, so basis of safety is to consider avoidance of hot surfaces. And a powder having MIT value less than 200 degrees Celsius is highly sensitive to hot surface. So, basis of safety to be considered, that is, first, temperature interlock. Second, divide the operation into batches where there is a continuous running of operation. And third, no dry run during operation. Since the MIT test is conducted for a small sample size, a correction can be taken into consideration for safe operating temperature based on 2/3 of MIT value. Determination of ignition sensitivity of dust layer. In order to determine how easily and with what quantum a dust layer can be ignited, LIT layer test is performed. Minimum ignition temperature for dust layer or layer ignition test LIT. Test procedure. The density of powder layer, packing density, is calculated by knowing the volume of containment ring and by weighing the dust ring before and after it has been filled with a level layer of powder. The apparatus, a temperature control hot plate, is set up in a position free from draughts but capable for extracting smoke and fumes. The ambient temperature is recorded and then the melt. Containment ring is placed centrally on the hot plate and a sample measuring the thermocouple placed in position. The 12.7 mm dust layer is formed by placing the sample into the ring with a spatula and distributing mainly with the sideways movement movement of spatula until the ring is slightly overfilled. The layer is then leveled by drawing a straight edge across the top of the ring. Any excess material is then removed from the surface of the hot plate. A screening test is initially performed where the hot plate temperature is ramped at approximately 5K per minute up to the maximum temperature of 400 degrees Celsius. All the information is collected using a computer controlled data logging system. The resultant computer trace is analyzed to determine an estimated start point for the isothermal testing. Isothermal testing continue with the hot plate being set to be predetermined start temperature. The test continue until it has been ascertained that either layer has ignited visible flame or has self-heated without ignition, that is glowing. If after a period of 30 minutes no ignition or self-heating is apparent, then test is terminated and repeated at higher temperature. If ignition or self-heating occur, then test is repeated at lower temperature, if necessary, prolonging the test beyond the 30 minutes. The test is complete only when temperature are established that result in a 10 degrees Celsius difference between an ignition and no ignition. If no ignition occur at 400 degrees Celsius, tests are repeated at 200 and 300 degrees Celsius to confirm the no ignition result. Result and interpretation. The LIT layer is defined as being the lowest temperature of hot surface capable of igniting 5 mm layer of powder. Ignition is signified by visible glowing or flaming is observed or a temperature rise of 50 degrees Celsius. A safety margin of 75 degrees Celsius is applied to experimental LIT layer value when the data is used to define the maximum surface temperature of enclosed for electrical equipments. Basis of safety. Since the LIT test is conducted for a small sample size, the correction can be taken into consideration for safe operating temperature based on LIT value as mentioned. Other type of basis of safety can be considered which are quite generic as mentioned below, like avoidance of hot surface and good housekeeping to avoid formation of considerable dust layer which can be fuel into a secondary dust explosion. If you find this video informative and useful, please like and share the video, and don't forget to subscribe our channel so you will get notification about our latest video. You can also connect with us on our blog and Facebook page. Link are shared in description box. तो मिलते हैं हमारे अगले वीडियो पाउडर सेफ्टी पार्ट 3 में. तब तक के लिए मैं रोहित साइनिंग ऑफ. बाय बाय.